Okay, so in this problem we have two circles having radii r1 and r2 which intersect orthogonally. Now we have to find the length of their common chord. Now let us see how to solve this question.
पहले हम इसके लिए एक डायग्राम बनाते हैं जिसमें दो सर्कल्स हैं एंड ऑर्थोगोनली कट कर रहे हैं, मतलब उन दोनों के बीच का एंगल 90 डिग्री है.
Right?
उनके सेंटर C1 C2 अगर लें और उनका ये डिस्टेंस D और हम अज्यूम ये कॉमन कॉर्ड हमको पता है और हमको पता है कि लाइन जॉइनिंग द सेंटर्स बाइसेक्ट्स द कॉमन कॉर्ड, मतलब ये दोनों लेंथ इक्वल है.
Right, that's well known.
एंड इवन द कॉमन कॉर्ड जो है उसके 90 डिग्री पे होता है.
Right.
एंड हमको पता है ये दोनों रेडियस R1 R2 है.
Right.
और हमको पता है अगर दो सर्कल ऑर्थोगोनल हो और उनके सेंटर्स के बीच में डिस्टेंस D हो, सो एक कंडीशन हमने थ्री पॉइंट्स में पढ़ा था, D स्क्वायर इक्वल R1 स्क्वायर प्लस R2 स्क्वायर, मतलब cos थीटा होता है R1 स्क्वायर प्लस R2 स्क्वायर माइनस D स्क्वायर बाई 2R1 R2.
Okay, yeah.
सो इसलिए हम क्या करेंगे, इस यहाँ पे थीटा आता है 90 π/2, सो cos π/2 इज 0. से अब हमको इसमें से एक कंडीशन मिला. सो हम अज्यूम करते हैं कि कॉमन कोड का लेंथ अगर 2h है, ये बाइसेक्ट हो रहा है इसलिए h है. सो अभी हम क्या करेंगे, पाइथागोरस थ्योरम अप्लाई करेंगे इस ट्राइंगल में. R1 स्क्वायर इक्वल्स टू h स्क्वायर प्लस इस दोनों टुकड़ों को D1 और D2 ले लेंगे एंड वी नो दैट D1 प्लस D2 इक्वल्स टू D. D1 स्क्वायर, दिस इम्प्लाइज D1 इक्वल्स टू रूट ओवर R1 स्क्वायर माइनस h स्क्वायर. यहाँ से पूरा हमें बस इक्वेशन सॉल्व करना है. कोई बस ये सब थियरी याद रहना चाहिए कि एक कंडीशन होता है, अरे बाइसेक्ट होता है वो सब, बस उसके बाद पूरा बेसिक नॉलेज ही है. D2 इक्वल्स टू रूट ओवर R2 स्क्वायर माइनस h स्क्वायर. अभी हम इन दोनों को ऐड करेंगे तो हमें D मिलेगा. सो प्लस रूट ओवर R2 स्क्वायर माइनस h स्क्वायर. नेक्स्ट हम इसको स्क्वायर करेंगे अगर, तो a प्लस बी होल स्क्वायर का हमें फॉर्मूला पता है, 2R1 2ab भी होगा, सो इसलिए इनटू. उसके बाद हम जानते हैं कि D स्क्वायर इक्वल्स टू R1 स्क्वायर प्लस R2 स्क्वायर, इसलिए हम कैंसिल कर देते हैं.
राइट.
और h स्क्वायर को इस तरफ लेके जाएंगे तो हमको 2h स्क्वायर आएगा इक्वल्स टू 2 रूट ओवर R1 स्क्वायर माइनस h स्क्वायर बाई रूट टू R2 स्क्वायर माइनस h स्क्वायर. 2 कैंसिल. अब इसको फिर हम स्क्वायर करेंगे.
राइट.
तो हम अब मल्टीप्लाई कर रहे हैं तो हमें आएगा R1 स्क्वायर R2 स्क्वायर, इन दोनों को स्क्वायर रूट निकल जाएगा ना, तो मल्टीप्लाई करेंगे तो हमको ऐसा कुछ आएगा h स्क्वायर इंटू R1 स्क्वायर प्लस R2 स्क्वायर प्लस h पावर 4. कैंसिल कर देंगे इन दोनों को. इसको इस साइड लेके जाके रीअरेंज करेंगे तो हमको मिलेगा h इक्वल्स टू R1 R2 बाई रूट ओवर R1 स्क्वायर प्लस R2 स्क्वायर. लेकिन हमको पता है कि कॉमन कॉर्ड का लेंथ 2h है. So this implies length of common chord, that is 2h equals to 2R1 R2 by root over R1 square plus R2 square.
Yeah.
So correct. It is our option A.
Alright, so we have question 6 over here which says equation of the circle that cuts the circle x square plus y square is equal to a square, x minus b whole square plus y square is equal to a square, and x square plus y minus c whole square is equal to a square orthogonally is. 4 options are given. Okay, so 3 circles are given and we have to find the equation of the circle that cuts all 3 of them orthogonally. I think there's a well-known concept for that we've learned before.
Yes, the concept which we're using here is like if the 3 circles are given and we have to find the equation of the circle which cuts them orthogonally, then the equation of the circle is with the center which is the radical center of these 3 circles, and the radius of the circle is the length of the tangent from the radical center to any of the circles, because the radical center is a point from which the length of tangents to all 3 circles will be same.
Okay.
So first we'll find the radical center of the given circles.
Okay.
We'll write the equation of the 3 circles given, which is x square plus y square equals to a square, x square minus 2bx plus b square plus y square equals to a square, x square plus y square minus 2cy plus c square equals to a square.
That's just opening up the terms.
On subtracting the first and second equations, we have 2bx minus b square equal to 0, which implies x equals to b by 2. And on subtracting the second and third equation, we have 2cy minus 2bx plus b square minus c square equal to 0. But since we know x equals to b by 2, on substituting that we'll get y equals to c by 2.
Okay, so what we did here was we found out the
Radical
equation of the two lines by subtracting the circles from each other, like c1 minus c2 and c2 minus c3, and we found out the point of intersection of those two lines, right?
Because we get the radical center by the point of intersection of their common chords, which is obtained by subtracting the given circle equations.
Right. So we found out the common chords first, and then we found out the point of intersection of.
Now we'll find the length of the tangent from the radical center to any of the circle. Since we know that the length of the tangent from a given point to a circle is root over s11.
Okay.
So we'll do that thing.
Let's see what that means exactly. Root over s11.
Like s11 is obtained by substituting the point in the given circle equation.
Okay.
So on substituting the point b comma 2 comma c b by 2 comma c by 2 in the for example, if we take the third equation, substitute in that, we'll get s11 equals to b square by 4 plus c square by 4 plus c square minus 2c into c by 2 minus a square, which is equals to b square by 4 plus c square by 4 minus a square.
Okay.
But the length of the tangent is root over s11.
Right.
So since we know the center of the circle and the radius of the circle, we can easily find the equation of the circle. So which is, since we know the center is minus b by 2 comma c by 2,
Right. Which is our radical center.
and root over s11 is the radius,
Okay.
the equation of the circle is on squaring we will get b square by 4 and plus c square by 4 on the left side and also on the right side. So on
Which will get
cancel,
cancelled.
yeah, they will get cancelled and we'll get the equation of the circle as the follows. So this is the equation of the circle which cuts the all three circles orthogonally.
Okay. Alright, so what we saw in this question was that you had to find the equation of the circle which cuts all three given circles orthogonally. Now for this we have this concept where you first find the radical center, and you find out the radical center by finding out the point of intersection of common chords. And how do you find common chords? Between any two circles C1 and C2, the common chord is nothing but C1 minus C2.
A small correction: if there are no common chords, then we'll just subtract the two equation circle to get the radical axis.
Okay. And how do we proceed from the radical axis?
Like the radical center is obtained by the point of intersection of the radical axis for the since we have the three circles, we'll get three radical axes. So if you point the intersection of any of the two
radical axis. All right, fine. So again you have to apply the same concept of subtracting the two circles from each other, and then you get the common chord or the radical axis and finding the point of intersection of any two of them so that you get the radical center. Now this was for finding the center. For finding out the radius, what you do is substitute the radical center in say any of the equations to get S11, and your root of S11 is nothing but your radius of the radical circle that we are trying to find out, or that represents your length of tangent from the say the
radical point.
Length
Radical center.
Length of tangent from the radical center to the given circle, any of the circles that you choose to work on.
But we also know that the length of the tangent from the radical center to any of the circles is equal.
Yeah, that is why you can choose any circle, you will get the same radius. So that is how you find out the center and radius, and then finding out the equation of the circle is a pretty simple job. Alright, so that was question number 6. Alright, so we have question 7 over here, which says the equation of the radical of a coaxial system of circle whose limiting points are 2, -1 and -3, 2 is 4 options are given. Alright, so first let's see what is a limiting point.
In a coaxial system of circles, the limiting points are the members for which the circle's radius is 0.
Okay. All right. So, and what exactly is a coaxial system of circle?
Like coaxial system of circles is just a system of circles of different circles which
Okay.
have a same radical axis.
Okay.
So
All right. All right. So, which different circles which have the same radical axis constitutes your coaxial system, and in that system, if the point where your radius is 0, the point where if you draw a circle with radius 0 are the limiting points. So, in this question, the limiting points are given to us.
Yes.
Okay.
So we'll
let's-
find the equation of the circles whose limiting points are 2, -1 and -3, 2, which is
Okay.
given by and the other equation.
So, do these circles have any special name since they are the circles of radius 0 about limiting points?
They just all the limiting points.
Okay. Okay.
Since we know that the radical axis for a system of two circles can be obtained by subtracting the equation,
Okay.
we'll just subtract the equation of these two circles to find the radical axis, which has to be found in our given question.
Okay.
So on subtracting the given equations, we get the radical axis of these two circles as on dividing by 2. So this is the radical axis.
Okay. All right. So pretty simple question, but one thing you need to make sure is that don't get confused by the big terms in the question like I did. First try to understand. First we saw what is coaxial system of circle. Then we saw what is the meaning of limiting points, and what we had to find out in the question was the radical axis. Now limiting points are given to us, so we can find out the equations of the circle about the limiting point, with center as the limiting point and the radius is 0. So we found out the two equations, and then simply for radical axis of any two circles, what you need to do is subtract the two circles. So we've subtracted the equation of the two circles from each other and got the equation of the radical axis. Pretty simple question. Just try to understand the concept and apply the basic equations. Alright, so that was question number 7. Alright, so we have question 8 over here, which says if mi comma 1 by mi are 4 distinct points in a circle, then m1, m2, m3, m4 is equal to 1, -1, 1 by 2, or 1 by m1 plus 1 by m2 plus 1 by m3 plus 1 by m4 is equal to 1 by 4. Okay, so let's see how to solve this question.
See, since they have given just points on a circle, not a particular circle, so we'll take the standard equation of the circle, which is x square plus y square plus 2gx plus 2fy plus c equal to 0.
Okay.
So in the given points, we'll just take any one of the point, like mi comma 1 by mi.
Okay.
It's a standard point.
Right.
Since it lies on the circle, we'll substitute the point, and since it lies on the circle, on substituting that point, it should be equal to 0.
Right.
So mi square plus 1 by mi square plus 2gmi plus 2f by mi plus c equals to 0. On multiply by mi square,
Okay, so you're saying that since nothing else was given apart from the fact that 4 points lie on a circle, so we took a general equation of a circle and substitute the points in that equation.
now we have obtained a polynomial of degree 4.
Right.
But from the polynomials chapter, we know that the product here, the roots of the given equation, the given polynomial are m1, m2, m3, m4.
Exactly. Nothing but the points.
Yeah.
Okay.
But we also know that the product, like different conditions, like the sum of the roots m1 plus m2 plus m3 plus m4 is minus b by a, which in
Okay.
our question is minus 2g.
Okay.
Similarly, the product of the roots m1, m2, m3, m4 is minus d by a,
Okay.
which is in our given question.
So let's see what the product of the roots is.
Sorry, it's d by a, not minus d by
Okay. So D here is 1 and A is also 1 here. Okay, so what we did in this question was, all right. So there's one more doubt, as in, how come we end up with a 4-degree polynomial in terms of m? I mean, couldn't there be, if there were 5 points given, say 5 distinct points passing through a circle, then what would we have done? If we would have proceeded with this approach, then again we would have got a 4-degree polynomial. Is there any reason that we are ending up with a 4-degree polynomial only?
Means see, the given points are like they have with the degree of 1 and minus 1, like mi, and the other point is mi power minus 1.
Right.
But in the given equation of our circle is a quadratic equation.
Right.
So,
that is why, okay.
So when we see that there is no denominator in the term in the equation after substituting the point, and after taking it we
Yeah.
get the power 4. It's not any condition that like there are 4 points, the degree will be 4, 5 point
Okay.
degree 5.
All right. Okay, so you're saying that interesting. This is very interesting. That since the form of the coordinates given, I mean x and y coordinates of the points given were such that if one is mi, the other is mi power minus 1. So when we try to eliminate the denominator in the equation, then we get the equation in terms of degree 4 polynomial. It is not like, ki if the 4 points are given, then the polynomial will be of degree 4 or 5. That is based on the form of the coordinates given. Alright, so that is something interesting that we saw. So what we saw in this question was that since 4 points were given, all we knew was that we took a random equation of a circle and we substituted the points in terms of mi, and then we simplified the polynomial. Now from the options it is evident that what we have to find out is the product of the polynomials. So we know that if we know the equation product of the terms m1, m2, m3, m4, so since we knew the polynomial, we directly put the formula of the product of the terms, which is d by a, which turns out to be 1 over here, which is option 1. Alright, so that was question number 8.